Alright, we're looking at the review for lessons 4.7 through 4.9. We can start with questions 1 through 3. This is asking us to find the length of CD. So length is referring to arc length, which is S. S is equal to the measure of the arc divided by the entire circle, which is 360 degrees, times the circumference. So here's the circumference, and this aspect here is the ratio of CD, arc CD, to the entire circle, which is the 360 degrees. So in this case, we know that the arc measure is 80 degrees, and we know that the radius is 3 inches. So we can simplify this. I always suggest that you simplify the ratio as soon as you can. So 80 over 360 reduces down, if you divide the top and bottom by 40, reduces to 2/9. And 3 times 2 is 6. So we have that the circumference is 6 pi. So we end up with 12 pi ninths, which if we reduce by dividing the top and bottom by 3, we get 4 pi thirds. For question number 2, we need to find the length of EF. So here's that arc, EF, and the arc measure is 120. So 120 divided by 360 times the circumference, which is 2 pi times the radius. In this case, it's 12 meters. This just reminded me. We need to make sure we mention that this is in inches. I'll just write inches. Okay. So if we simplify this, you know that 120 over 360 is equal to 12/36. And if you reduce that by dividing the top and bottom by 12, you get 1/3. And then 2 times 12 is 24. So we have 1/3 of 24 pi, or 1/3 times 24 pi, which gives us 8 pi. This is in meters. Okay, finally, with question 3, we're asked to find, and be careful, it says BIG. So again, this is a major arc. You start at B, pass through I, and end at G. So start at B, pass through I, and end at G. You'll notice that the rest of the circle is 150 degrees, which means that BIG must be the remainder of 360. So 360 minus 150 is 210. So once again, we're looking for that arc length, so we take the arc measure over 360 degrees and multiply it by the circumference. And in this case, our radius is 12. So to evaluate, we know 210 can be reduced to 21/36, which reduces even further, right? You can divide the top and bottom by 3. Divide the top by 3, you get 7. Divide the bottom by 3, you get 12. So you get 12 times 24 pi. Now you can reduce this. 7 times 24 pi divided by 12. You'll notice that if you divide the top and bottom by 12, you end up with, and I'll leave the denominator there so you can see clearly, 7 times 2 pi is 14 pi. So we have 14 pi over 1, which is just 14 pi, and this is in centimeters. I think we should cruise through 4, 5, and 6. So we're given the length of AB. So this is different from the previous questions. We're given the arc measure, but here we're given the arc length. So from A to B is 6 pi units. So we're trying to find the radius here. So we can harken back to S is equal to the arc measure divided by 360 times 2 pi r, and say, well, in this case, the arc is 6 pi, and the arc length is 6 pi, and the arc length is equal to the measure of the arc over 360 times 2 pi r. So here, the only variable we have is r. We can solve for r. First of all, I want to reduce 120 360ths because we know already from a previous question. This reduces to 1/3. Now, it seems the easiest way to do this is to start by dividing both sides by 2 pi. You'll notice that the pi's cancel, and on the right hand side the 2 pi's cancel, but also 6 divided by 2 reduces to 3. So we end up with 3 is equal to 1/3 times r. Now to solve for r, since it's being multiplied by a fraction, we need to multiply both sides by the reciprocal of that fraction. If we multiply by the reciprocal, these cancel, right? And then on the left-hand side, we get 3 times 3 over 1, which is just 9. So 9 is equal to r. So we'll move this over here. The radius is 18 feet on this question, and we're given this inscribed angle whose endpoints make the arc RT. So, since this is an inscribed angle, you know that the intercepted arc is 2 times that of the inscribed angle. So RT has a measure of 60 degrees. So we're ready to set up the equation, or the formula for arc length. So arc length is the arc measure over 360 times 2 pi, and in this case our radius is 18. We end up with 1/6 times 2 times 38 is 36. So we get 1/6 of 36 pi, which is just 36 pi divided by 6. So we end up with 6 pi. 6 pi feet. Alright, now for this question here, we're given the length, so S is equal to 12 pi in this case. So we know that 12 pi is equal to the measure of the arc over 360 times 2 pi r. For this problem though, we're just given the measure of the inscribed angle, which is 80 degrees. Since it's an inscribed angle, its intercepted arc is 2 times the inscribed angle. So TV, the measure of TV, I'll write this right here, the measure of TV is equal to 160. So that's what goes up in that numerator there. Okay, we can simplify this. I know that 160 360th reduces to 16/36. which if we divided the top and bottom by 4, we would get 4/9. So I'll rewrite this. I'll say 4/9 times 2 pi times r is equal to 12 pi. Again, the easiest thing to do in this case is start by dividing both sides by 2 pi. You'll notice that these cancel, your pi's cancel, and then 12 divided by 2 is 6. So 6 is equal to 4/9 times r. Once again, our variable is being multiplied by a fraction, so we must multiply both sides by the reciprocal. What we get is, these cancel, all that's left on the right side is r, and then on the left side, 6 times 9 is 54, so we have 54/4, which reduces to, if you divide the top and bottom by 2, we get 27/2. This question, though, isn't asking for the radius, it's asking for the diameter. That's easy, right? We know that the diameter is equal to 2r, right? It's 2 times the length of the radius. And in this case, 2 times 27/2. The 2's cancel, and all you're left with is 27. So the diameter is equal to 27 inches.